This is question 9 of the 2019 higher level Leaving Cert paper. As you can see, it's split up into 5 questions, and honestly they're not too bad except for the last one, part E. That's a little tricky, but even that, nothing too bad. If you remember your basic geometry and trigonometry, this question should be fine. Do not get over intimidated by it. Just try and answer each part as you can. If you get stuck on any one part, stay trying to answer everything about this image. Everything about both of these images. The first 4 parts deal with the first one there. Just answer everything you can and then redo the questions. You may have found a different path to the answer. And in fact, there will be different paths to the answer than I'm going to show. I will probably show the fastest path to it, but there may be more roundabout way ones. There also may be faster ones than I show. Here I've drawn out the information they've given us. We have a triangle GHS with a circle inside it. It's an in circle. They point out that it is a right angle here to the radius. So there's more things we know about in circles, and that's actually going to help us for part E. I'll leave it as a spoiler until then, or more importantly, I'll wait until then to make sure anybody skips into that part hears it, so I don't give the information now. Okay, part A asks us to find SG, the length of this up here. I always like to redraw the triangle because this is too complicated, too much information there. I like to just do a nice rough drawing. We have 68, 58 and 30. And also I like to always look at a triangle and think, do I know 3 things? Because that's all I need. I need 3 things and I can find everything. They're asking for this length here. Let's put a little X there. We can find this. We can use the cosine rule, which says, it'll be in your formula book. It's a squared is equal to b squared plus c squared. Well, I'll write it out here with these numbers. X squared, the length here, is equal to the other side's squared. 58 squared plus 30 squared. That's Pythagoras theorem, except it's wrong because this isn't 90 degrees. So here's what makes it different to Pythagoras theorem. We get, oh I'm sorry, that's also wrong. We get 2 times both these sides, 30 times 58. Let me just check this. It's been a while since I've done used the cosine rule. Times cosine of this angle, opposite the one we were dealing with, 68. So that's it. I don't want to write that out again, so let me cheat here and just say this is, let me just say x is equal to the square root of x squared. Or well, plus or minus. We'll leave a plus or minus for now. Which is equal, put all this into your calculator, get the square root of all of this, So get all this and get the square root of it, and we will get out, to correct 1 decimal place, 4.4. Plus or minus 4.4. Therefore, x, you don't need this, you don't need to have wrote the minus. X is equal 54.4. Oh, 54.4. In fact, you would lose a mark leaving the minus as the very last thing, because of course you can't have a minus in a geometrical question, in real life length. We can't have it. Alright, so that's part A. Let me rub this out and we'll do part B. So part B is asking us to find the angle HSG. HSG. This angle up here, once again, I'll draw the triangle. Doesn't have to be very accurate, it just has to be roughly to help your mind think, it's nothing else. Put in all the numbers, we know 58, 30, 54.4. I don't necessarily like using 54.4. I would advise using more decimal places from our previous part. Oh, I don't have it written down. Yeah, I would always advise using more decimal places if you're going to go ahead and use that in the next part. Although this answer requires degree to 2 decimal places. I would like to use more decimal places. I don't have them written down. I'll just carry on, but I'll just point that out. There could be a problem. In fact, in this question, in the answer scheme for part E, it gives 2 answers, and 2 correct answers with different decimal points. And that's because they rounded off too much. And even the exam's happy enough with that. I guess I'm not, although I'm about to do it. So what do I know? Okay, so how do we solve this? 4 things we know about this triangle. Should be many options. The sine rule jumps out at me. A length over an angle, length over an angle. We're looking for this guy up here. Cosine rule, length with an angle, and we have the other two lengths. Both of them. I like to use the sine rule when I can. So I will get, let's put the angles on top. Sine 68 divided by 54.4 is equal to sine theta, the unknown angle here, divided by 30. So let's just rearrange that. We will get sine theta is equal to sine 68 multiply the 30. This 30 will multiply both sides, destroyed. It will appear on this. I flipped them over though. Hopefully you're okay with this. I am talking to honours level students, hopefully. That's just simple algebra, rearranging it. Double check you're happy with that. And then theta is equal, the inverse sine to destroy this guy. The inverse sine to both sides will destroy this one, and it'll appear on this side. And 30 sine 68 divided by 54.4. You need to put that into a calculator, which I've already done. Put that into, let me check I have these numbers right. Yeah, put that into a calculator and we'll get 30.75, or at least rounded to the nearest two decimal places. I would advise, go back, get a more accurate number here. Save this number in your calculator from the previous part and see if this changes. Have we made a mistake here because of our rounding error? I'd advise you to double check things like that. Okay, part C. Will I fit? No, I'll continue. I'll rub this out and I'll do part C on its own. Part C asks me to find the area of SGH, the triangle SGH. So we just need to find the area of this triangle. Go to our tables, look up the rules for triangles. We all remember a half the base times the height. I don't see an obvious way to get the perpendicular height here. Well, except for the formula I already know. We could work out the height, but we don't have to because we already know a formula. Given any triangle, a formula of the area is equal to a half AB sine C. So that's a triangle with three sides. Say A, angle A, length A, angle A, length B, angle B, length C, angle C. Something like that, which we have everything we need for that. Really, we just need a length, and an angle in between them. Will always give us an area, which we have that. We don't even need any of the new numbers we found, which, by the way, let me fill them in here. 54.4, and the angle in here was 30.75. We'll keep that there for every part. Okay, so we just need to fill this in. It's quite so short. A half A could be 30, B could be 58, and sine C could be 68. That's it. We just need to put that into a calculator and you should get out the answer. Again, I'm just double checking my numbers. You should get out the answer 806.65. Which, did they ask for two decimal places? Yeah, find the area to two decimal places. There we go. Okay, I'll rub this out again and we'll do part D. We're flying through this. Part D asks us to find the area of HSP. The area of HSP. This new triangle here, let me draw that. This new triangle here, HSP, just to make sure we're all on the same page. In terms of OR, they give us that option, in terms of OR. And look, we do already have OR here, and that's a right angle. So that's quite convenient for us. This is 58. That's pretty much all we need. The area of a triangle is equal to a half the base, 58, by the perpendicular height, which is OR. So this is half of this is 25 plus 4, which is 29. 29 OR. That's that's the answer I have there. Simple as that. That is the area of this triangle in terms of OR. So let's jump on and do part 2 here, because they're all linked together. That's they often do this to help us out. Show that the area of SGH, the triangle SGH, that's the entire triangle. Show that the area of that is, let's say I put in here A, is equal to, oh, I'm sorry, not an equals there. the area of this is, let's put a bracket, is equal to 71.2 or. So show this. Now we've already got the area on a previous part. It is equal, let me leave it up over here. Area is equal 806.65. So we have already got the area, but now they'd like to show that the area is equal to this. So how do we do that? So let me redraw this. Let me put in the circle this time. So here is this image again, and we've just found the area of this triangle. So the trick here, the area of this triangle was really easy to find in terms of or. So that means the area of this triangle here, which also has a height or, should be really easy to find. The area of this triangle here, which also has a height or, should be really easy to find. So the area of these triangles is actually just 29 or. We've already know one of them. And well, let me do it out. I'll write this again just to make it a bit clearer. The area of this triangle is a half 58 or, plus the area of this triangle here has a base 30. This is 30, and it has a height or, is also a half 30 or. This one here is 54.4. This is also a half times the base is 54.4, and it has a height or. So really this is where we're going to get to this number, and you can just type this into a calculator and you'll get there. Let me just do it like this. A half or goes into all of them. 58 plus 30 plus 54.4, which is equal, well, if you do it, I'm not going to waste my time doing it out, 71.2 or. I assume I've double checked that somewhere. Yeah, I got the same answer as this, or well, make sure you do. Although, hopefully it does come out as the same. If not, you've made a slight mistake somewhere. Find that mistake. Don't lose marks because of it. Okay, part 3 of this is find the value of or. I'm running out of room, but I have plenty to do this. They tell us the area of the triangle is this. They tell us the area of the triangle is this. So it's simply 71.2 or is equal to 806.65. Or is equal 806.65 divided by 71.2. Or comes out to equal 11.3. Again, that's rounded to the nearest one decimal place. Or is equal 11.3. Let's put that into up here so we have it in future. And I'll rub this out and we'll do part E. Okay, here is part E, and they've given us extra drawing. We have this three-dimensional image. I hope that's clear on mine, but still, you should be able to see it if you go to the question. It's in the comments below if I didn't mention that. And we're looking for the height of this pole here, the height of T. So we really just have to play around with this question until we get this. I would point out a couple of triangles here. We have this triangle up here looking straight down on it. Another triangle that would be of great interest to us is S, T and P. And it gives us information, doesn't it? It tells us the angle here is 14. How does it phrase that? Let me see. The angle of elevation of the top of the pole from P, coming from P, is 14. So that was an extra little question asking, could you understand that? Could you read that sentence and put the number 14 there? Brilliant, we've got that. Well, I've got it. Hopefully you've got it too. So this question really just comes down to, because we have a right angle, we have a length, we just need to get one of these lengths. We're looking for this one. So I think PS, since PS is on this here, PS is what we should be looking for. So let's just boil this question down to finding PS first. So let me draw this again. We will get, here is P here, and here is S. I need to get this length. So the question really comes down to finding it. We know this here, this is 11.3. We know that's a right angle. So there's a triangle I'd like to focus on. Now you can play around with this all day. The job is just to get the length of here. This is X here, the length from P to S. Let me put that in again here, P to S. This is going to be probably the fastest way I'm going to show you. It doesn't mean it's the only way. You can fill in all the numbers until you get there. Once you get there, So here is though the trick. I would say there's a few different ones. I would pull this triangle out here again. Let's draw this again up here. This is S. Let's name this guy here A. P. So I have 11.3. I have an angle. And I have this entire angle here. Here's where a bit of knowledge is required. And this is where probably without this knowledge a lot of students wouldn't have been able to continue. I know this angle here. This angle here is in fact 15.375. Let me write that out again here. 15.375. How do I know that? It's half of this angle. And in circle, all of these angles, these bisect, all of these. This is a known thing to us, or at least it should be a known thing to us. Just to quickly show why that is, a lot of you might be wondering, we have these radiuses here. If I look at these two triangles here, right angle, this triangle and this triangle, actually let me just draw them out again. It looks a little like this. We have a right angle and a right angle. We have the same line down the middle, same line. This is OR, this is OR. And what else do we know? Oh, that's the three things we know. Okay, that's enough. We know the length is the same as this length. We know this length is the same as this length. And we know this angle is the same as this angle. They have three things in common. These are similar triangles. That means everything is the same in these triangles. That means this guy equals this guy. Or, I don't know why I proved it down here when I wanted up here, but this is true for all three sides. It bisects all of these angles. It bisects this angle here. You don't need that, by the way. You don't need to do that. You're allowed to just know it. Well, unfortunately, you do need to know it. But you don't have to prove it. Not in this part, not in this question. They might ask you some other time to prove it. Okay, so we have this. And remember, all we're really looking for is PS here. PS on this image. Looking at the side, PS here. So if we get that, we should be able to find TS. So PS, let me instead of using X, I'll just use PS here. PS is equal to, or let me rub that out. Let's get a formula involving PS. We have an angle, we have a length, we have a right angle triangle. So it looks to me that the sine angle here will work. Sine 15.375 of the opposite, is equal to the opposite divided by the hypotenuse, PS. Which that's what we're looking for. Rearrange that and we get PS is equal to 11.3 divided by sine 15.375, which that is equal to 42.619. Let me just double check that is the same thing. I believe that's the correct number for this. So we can go ahead and use that over here. I think I would probably have enough room to do it here. Yeah, I don't need this drawing. Let's rub that out. We have it again up here. So let's go back in our question. I'd expect you to do this a little neater in your exam. I'm not a very neat person in my head. This number here is 42.619. I'd save this in my calculator. It should be right in my calculator. I'll get TS here over here. Should be the last thing I put in my calculator, this number, so I should have it perfectly. TS, I want a formula with this. I have this length and I have this angle. That looks to me the tan formula. Tangent of 14 should be equal to the opposite, TS, divided by the adjacent, which is 42.619. Rearrange this, we get TS is equal to 42.619 multiplied by tangent of 14. Again, this perfect number is on your calculator, you don't need to round it, although it's probably been rounded many times. Yeah, this number here was rounded off. We got this from this one, that was rounded off. There's been a lot of rounding off through this question. To keep the perfect number in your calculator, you would have had to save it each time, or just write out the formulas each time. Anyway, if you put this one into your calculator, you will get 10.6 to the nearest one decimal place. I see in the marking scheme though, if you did do it slightly different ways, you would have ended up with 10.7 as an answer. That's just because this wasn't exact. I don't like doing it, but the exam sort of walked me into doing it. I don't like rounding off early on in a question when the answer relies on this number. So we rounded off, we got this. We rounded that off. We used that to get, actually I think the other things we got from original numbers, but we used these two guys down in this final answer, which makes this rounded off. But anyway, it's close enough and the exam's happy enough with it. So that's the final answer. If you have any questions about any of this, leave it in the comments below. I will get back to you as best I can. Thanks for watching and goodbye.